So, sorry about that. This is the video recording to help out with the Unit 7 lab, the one about hydrocarbons, modeling organic compounds, right? So if you're getting to it on time, it'll show up on December 2nd in the class plan for this block. But for those of you that may be in a different block or get to it a little bit past the due date, if you click on plan and look for 7.02 on your calendar, that's where you're going to find it. So let's see, light pink is this class. There's 7.02. There we go, laboratory modeling organic compounds. All right. So you definitely want to read through, especially this part, the laboratory section. It gives you some good background information. You'll also want to read through the introductory information on in the lab manual, okay? But the big thing you want to get off the internet before you end up starting is your lab report. So make sure you download and grab that. It's a Word file that looks kind of like this. And then just so you know, and while it's not going to say this, because the file's already uploaded on there, this first question is going to be 17 points. I'm throwing 10 points in there because this is where the bulk of your lab work is going to help you answer a question. The rest of this is just kind of reading through and making some general conclusions. All right, so these next two questions are pretty easy. This is the one where if you actually lab, you'll be able to tell. So I want to make that worth the most points. So if you open up your lab manual, which I have a version on here on the computer. So here's your objectives. This part in here, particularly understanding what the word isomer means, is a good thing you want to read and get out of here. All right. And we'll talk about isomers and I'll show you some examples of that as we get going. But this picture right here is ideally what your model should make the compounds look like. They're not going to unless you guys have better kits than I do. I have kind of what seems like a mesh of either what isn't supposed to be carbon or just random different kits that they have kind of taken parts and pieces out of and just happen to have the same colors. But we'll make do with what we have. One thing is we're going to stick to single bonds, so don't worry about that. But you are going to be building some models, right? So if we follow along, get into the procedure. So we need our molecular model kit, paper and pencil. Paper and pencil I think is going to come in the handiest because the kits just, I mean, they're nice, but they're not that great. So it says obtain a black ball, insert 4 bond sticks at each angle as far apart from each other as possible around the black ball shown in the photo. So they're assuming that you have styrofoam equipment so that you can stick the little pieces in wherever. That is not the case. What you guys have are something kind of like this, where there are defined holes on your atoms, all right? So you kind of have to go with wherever the holes are, and they don't necessarily fit. Some of the white pieces go in the hole really nicely. Sometimes they're a little too small, but just do your best. Depending on which variation you have, your methane might look like that one, or it might look like this one. Neither one of these are perfectly correct, but still you get the idea. Methane is going to be 1 carbon with all 4 bond sites filled with a hydrogen, or CH4. Okay, so that one's pretty easy. What you're doing on your piece of paper is for the first 10 hydrocarbons, so first one's methane, you're just making a brief drawing of it. You don't have to draw it perfectly to scale, but just something kind of like this. All right, so methane is CH4. And you're going to keep doing that. And the reason why I have 2 methanes is because the next step is you're going to go through and you're going to combine these to make a 2-carbon chain, which would be called ethane. And to do that, you're going to have to take off 1 hydrogen, which will give you some more tools to use later. you're going to have a hydrogen and a bond. Then you're going to take off just a hydrogen on the other one. And then you're going to hopefully get these to stick together without losing any pieces. Like that. Okay. So from another angle, it kind of looks like this. And when you draw it, a kind of just easy way to draw that on your piece of paper, and so you can see I'm not having the most success with this sticking around, but ethane is going to be 2 carbons and then 3 hydrogens coming off of each one. And then you're just going to keep adding methanes until you get to decane where you have a total of 10. All right. Once you kind of get the pattern down, you don't necessarily have to build every single one. Keep going, though, until you get a feel for where to drop bonds and things like that to combine them together. And then the big one that you need to pay attention to that you're going to determine the isomers of is heptane. So when you get there, the instructions tell you to take a methane. So here's my methane. And then just to save myself some frustration, what I did is I tried to get the yellow bonds, the yellow hydrogens onto every single one of my carbons in hexane. So this one is a 1, 2, 3, 4, 5, 6 carbon chains. That's hexane, right? So just pretend there's a yellow piece at all of these, and you're more than welcome to take that shortcut too. All right. The one thing I wouldn't do is to leave these white pieces off, because then you're going to forget something's there at all. Right? So if you at least use all the white pieces and then just recognize that at the tip of that represents a hydrogen, you'll have a pretty easy time with this. So what you've got to do to make heptane is what we did before. We're going to take, this bond, this hydrogen off the top of our methane. I'm going to take that away, and then I'm going to attach it to my hexane. Now, if my hexane will behave and not fall apart on me. So a couple of places I can do that. My hexane's not holding up right now. So I can put it on the very end one, down here, and make it a straight on carbon chain, all right? Or I could put it on the second one. That's called an isomer. Both of these molecules have the same number of carbons and the same number of hydrogens, so their formula is the same, but they look different because the positioning of where pieces are. I could do this again. I could put it on the middle one, or one of the middle ones. All right, so I could pop it on over here. And that would be a different isomer. All right. Now, if I go and I put it on over here, that's actually just the mirror image of the one that I did before, so that's not different. All right, so usually it's once you get to the middle carbon, then you start running into not being able to make new isomers. But then, to make more complicated isomers, what you could do is you could take this group of carbon and hydrogen, combine it with this one, so take an ethane, and now I have a pentane down here, which I need to put back together. Kind of, and attach 2 somewhere on a middle one, right? And then have a 2 branch. And so you don't necessarily, if you miss 1 or 2 of the isomers, or you have a couple of duplicates of them, I'm fine by that. But definitely, to get full credit on that first question, you're going to have to be able to tell me how many different isomers you got and describe how they're different from each other. You can, if you want, include the drawings that you make. Okay, so for example, for heptane, all right, there's going to be 1, 2, 3, 4, 5, 6, 7 carbons, and I could just do them in a straight line like this. And that's 1 isomer. I'm going to draw all my hydrogens on there. When you're doing the drawing, it's easy enough to put the hydrogens in and make sure that that's clear, and you'll need to do that. Okay, or I could have 1, 2, 3, 4, 5, 6, and do a 7th one there, and then draw my hydrogens. All right, and you know, if you get to the point where the model is just getting way too frustrating and you'd rather just draw these out, that's fine. You just have to keep in mind that every single carbon needs 4 bonds off of it. All right, and we're going to stick to single bonds. Don't worry about trying to do double bonds and making even more. Because technically that does change the formula because you're going to lose some hydrogen, so those are isomers. Those are different. So stick to single bonds. Okay? And then see how many different combinations here you can get. That's going to be the tricky part to the lab, right? Because the rest of it, the other 2 questions, looking at page 54 in your laboratory guide, note that butane has 2 possible isomers, but that decane has 75, right? What does the number of possible isomers, why does the number of possible isomers go up with an increasing number of carbon atoms, right? That one you can probably answer right now, or definitely after having figured out how many different isomers that there are for heptane, you'll have a much easier time answering that one. And then the last one, look at the table of boiling points on page 54 in your laboratory guide. These are the boiling points for the unbranched hydrocarbons listed. Consider your models and drawings based on your knowledge of bonding and chemical forces. Infer what might contribute to the increasing boiling points as carbon chains grow longer. So one thing, I'm going to give you a hint here. When it comes to that boiling point, think intermolecular forces. All right, this guy with the branch sticking out, is it going to be easy to line up one of him next to something else with a branch and get them real close together to strengthen those intermolecular forces? Or, and I'm missing hydrogen on that one, is it going to be easier to line up these straight chain guys real nice close together? All right, that's what you're thinking as far as that question goes. So remember, this first one, this is how I'm going to be able to tell if you did the lab, how well you answer this question. You better answer more than what an isomer is. I need some details as far as how you figured out how many different heptane isomers there are. All right. By 1, telling me an actual number, and 2, describing some of the differences. What might be the easiest thing for you to do here is to submit a picture of your drawing. Okay. So that is our presentation. Oops.